Section 3. Energy Transfer in Collisions. The game of billiards. The game of pool, also called pocket billiards, has a history that dates back to the 15th century in Northern Europe. It evolved from a game similar to croquet that was played outside, where a mallet is used to hit balls through hoops. This is why the cloth of the table today is green. It was intended to mimic the color of grass. The game was also the first sport to have a world championship. If you were to watch a game of billiards, you would see energy transfer and energy conservation happening with almost every turn. There are different kinds of billiards, but the scientific principles remain the same in all of them. Playing billiards. At the beginning of the game, solid and striped balls are grouped together, leaving out the cue ball, which is the white ball. Someone then breaks, which means that person uses a cue stick to hit the white cue ball toward the group of color balls. The cue ball is supposed to break up the group of solid and striped balls. You can think about the game of billiards as a system consisting of the balls and the table. The outside force of a person hitting the cue ball causes energy to transfer from the cue stick to the cue ball and then to the other balls. In a perfect system, the same amount of energy put into the cue ball is going to be conserved and transferred to the other balls because of the conservation of energy. In the real world, some energy transfers out of the system because of friction caused by the white cue ball moving across the table and drag as it moves through the air. Transferring energy. Whenever two objects come into contact with each other, both objects exert a force on each other. For example, when the cue ball hits another ball, the force of the collision transfers some of the cue ball's kinetic energy into the second ball. This transfer of energy changes the motion of the billiard balls. This is why the solid and striped balls begin to move after a break. The white cue ball has transferred kinetic energy that causes the other balls to move. If the cue ball is hit with a smaller force, it will have less energy to transfer to the other balls. If it is hit with a greater force, it will have more energy to transfer to the other balls. Motion after energy transfer. The motion of the white cue ball after it hits another ball depends on how exactly it hits the other ball. For example, the cue ball will stop moving if it travels in a straight line and hits the other ball exactly in the middle of the other ball. This is because of energy conservation. All of the energy from the white cue ball is transferred to the other ball. However, you'll often notice in a game of billiards that the cue ball keeps moving after hitting another ball. This is because the cue ball did not hit the other ball exactly in its middle. As a result, not all of the cue ball's energy is transferred to the other ball, so the cue ball keeps moving before friction eventually causes it to stop.